Welcome everyone for power system lectures. The first thing is what is a power system? So a power system is a network where we do the generation, transmission, distribution, and protection of the electrical systems. Understand? So it mainly consists of generation part, transmission, distribution, and protection. Okay. So the power system contains many devices like alternators or generators, motors, transformers, circuit breakers, relays, insulators, transmission lines, and lot of other devices which keep this power system intact. We require so many devices. Okay. And one more thing is the power system is the largest man-made network. Largest man-made network. Now, before understanding the philosophy of power system, we should get familiarized with few terms. You should understand the few terms. The first term is utility. Utility. So what is the utility? The entire body, the statutory body or a private body that does generation, transmission, distribution of electrical energy and brings down electrical energy to the customer premises. Customer premises. Okay. The customer may be an industrial customer or a domestic customer, irrigation customer, different types of customer. So all the system, all the body that is involved in bringing electrical energy to your household premises is called utility. Okay. Can anybody tell what is the utility from which you are getting the power supply to your house? So what is the utility that is getting from which you are getting the power supply to your house? Very good, very good. Kerala State Electricity Board. Very good. I'm happy. Now, the second thing is, what is the scope of utility? The responsibility and the scope of utility is still customer premises. Suppose if some halt happens anywhere in between the generating station to your house, till the premises of your house, it is the responsibility of utility to rectify that fault and resume the power supply at the earliest. Okay. Suppose once the phase neutral wire enters your meter, energy meter, after that, whatever happens, it is the responsibility of the customer. That means for every customer, there will be a metering panel. So after metering panel, the scope and the responsibility completely lies with the customer. If some electrical shock happens inside your house, then it is the fault of the customer itself. Utility will not take any responsibility. Understand? But till that metering panel, whatever happens, it is the responsibility of the utility to rectify the issue. Understand? So different utilities are the state electricity boards like TANGEDCO. TANGEDCO is the Tamil Nadu Generation and Distribution Corporation, Kerala State Electricity Board, like that. So most of the utilities are governed by the government authorities. So very few private players are present are present in or acting as the utilities. In Mumbai, you can find the Reliance is one of the private utility apart from the Maharashtra State Electricity Board. Okay. Now, the next point is customer. Who is the customer? The customer is the one who is purchasing electrical energy from the utility and paying money for that. He is the customer. So there are different types of customer. Domestic customers like ordinary households, commercial customers like movie theater owners, commercial complex owners, amusement malls owners, all they are the commercial customers. Industrial customers and irrigational customers. So different types of customers are there. Depending upon their demand and requirement, different tariffs are charged. The rate of electrical energy is different for different types of customers. Okay. The scope and responsibility of the customer is after his metering panel. After his metering panel. Okay, so you have to be familiar, you have to get familiarized with these two terms. One is the utility, other is the customer. Okay, so any doubt in this concept? Are you able to follow my language? Any discrepancy in that, you can just type in your chat box. Okay. So any doubts or anything? Okay, okay, boss. Okay, thank you. Thank you. Thank you. Now, next, the second term which I want you to get familiarized is the nominal voltage. Nominal voltage and nominal frequency. So in India, what is the first you understand the term what is nominal? Nominal means, suppose if I say nominal frequency, what is the frequency that we are supposed to get in our households or in our industries or in uh, for all our electrical appliances? What is the frequency? 50 hertz. We are supposed to get 50 hertz frequency for our all loads from the utility. So the value that we are supposed to get, that is called a nominal value. That is called nominal value. But if you measure the frequency at any point, the value may not match with the nominal value. Very rarely, very, very rarely it will match with the nominal value. There will be some fluctuation. There will be some fluctuation. Suppose you are getting a frequency, if you measure in your plug point in your house, then you are going to get, suppose this is the plug point, if you measure the frequency here, you're going to get 49.6 hertz or sometimes 50.2 hertz, because frequency is the parameter that is continuously fluctuating. So there is will be always a difference between the actual value or actual frequency you are getting and nominal value. So nominal value is the value which we are supposed to get. Likewise, nominal voltage. So what is the voltage that we are supposed to get between our phase and neutral? What is the nominal voltage which we are supposed to get? Yes. Very good, 230 volt, but that is not complete. 230 volt phase to neutral RMS value. You should specify the voltage as 230 volt phase to neutral RMS voltage. This is the voltage which which you are supposed to get. Suppose if I ask the question, what is the nominal voltage that we must get at the primary side or the HT side of the distribution transformer? I hope you know there will be a distribution transformer in every street which will step down the voltage to lower value, and there from the distribution will start. So what is the nominal voltage that we are supposed to get in our on the HT side of the distribution transformer? Very good, 11 kV. 11 kV is the right answer. 11 kV. So So 11 kV is the nominal voltage at the primary side of the distribution transformer. Likewise, if there is a 33 kV substation which is supplying to these distribution transformers, then the nominal voltage there is 33 kV. Likewise, at every point in the power system network, there is some nominal voltage. There is some nominal voltage. Understand? Okay. But the actual voltage that we are receiving at a point may be different. Understand? So what is the object here? The first point which you have to remember is that the first point is all the voltages in power system network are expressed as line to line RMS voltages. At every point, at any point in the power system, we specify the voltage as line to line RMS voltage. Only at the premises of a single phase customer, we specify phase to neutral voltage. We specify phase to neutral voltage. Understand? So I hope you are clear that what is a nominal voltage. Nominal voltage changes from one point to other point in power system network, whereas the nominal frequency is constant, which is at 50 hertz. Understand? And you remember this very, very important point. All the voltages in the power system network are expressed as line to line RMS voltage. Line to line RMS voltage. In transformers, if you see, what is a, suppose if it is a 33 kV bar 11 kV transformer, 33 kV is the high voltage, 11 kV is the low voltage. What is 33? 33 kV is the line to line RMS voltage on HT side, and 11 kV is the line to line RMS voltage on the low tension side. Okay. So like suppose somebody says 400 kV transmission line. So what is that 400 kV? 400 kV is the line to line RMS voltage of that transmission line. Likewise, at every point in power system network, the voltage is specified as line to line RMS voltage. Okay. Next. The next thing which I want to tell to you is what is power system? What is power system? So a power system is a big business between two parties. Who are the two parties? One is the utility, the other party is customer. Okay. So power system is a business between the utility and customer. So in any business, either you are selling a product or you are providing a service Many people think that, or you can perceive in either ways. In our business, can you tell me, are we providing service or are we selling something? In our power system business, are we providing some service or we are selling a product? Okay. Both. One of my friend told it is both. Okay. We are selling, we are providing a service. Okay. Let me tell. Let us assume that we are selling a product. We are selling a product. Then our product is what? Our product is electrical energy. Our product is electrical energy. Okay. So how do you quantify electrical energy? Okay. Suppose if I am selling bananas, I'll sell in dozens or hundreds. Mangoes, I'll sell in cages or something like that. How do you sell your electrical energy? You sell your electrical energy in units. You sell your electrical energy in units. So 1 unit of electrical energy means how much? It is 1 kilowatt hour of electrical energy. Okay. So that means 1 kilowatt means, kilo means 10 to the power of 3. Okay. So many watts into hour means 3600 seconds. Okay. So if you multiply both, it will become 3.6 into 10 power 6. So many watt into second. Watt into second is joule. So 1 unit of electrical energy means 3.6 million joule of energy. So for 3.6 million joule of energy in electrical form, you are paying a tariff of 6 rupees per unit or 8 rupees per unit, depending upon your slab. Depending upon your slab. So in our business, we are selling a product which is electrical energy, which is quantified in units. Which is quantified in units. 1 unit means 1 kilowatt hour. 1 kilowatt hour means 3.6 million joule of energy. Understand? So likewise, any customer, when he is buying a product, he has some expectations. He has some expectations. So since we are a customer, we are buying electrical energy. We want to buy quality electrical energy. Quality electrical energy. Not only quality, we require some other features from our supplier. What are the demands of the customer? The demands of the customer are he requires reliable electrical energy. He needs reliable electrical energy. The second feature is he requires quality electrical energy. Quality electrical energy. Okay. So can anybody tell? And the third feature which he wants is he needs cheap. He require it at a lower cost. Understand? So what is the first feature that the customer require from the utility? Reliability. What is the reliability? Uninterrupted power supply. Whenever I want, how much ever I want, that much electrical energy should be available for my usage. That is the reliability. Whenever I want, how much ever I want, that much amount of electrical energy should be available for my usage. That feature is called reliability. Reliability. Understand? Obviously, the second feature is cheap electrical energy. We want the electrical energy at lower rates. We want the electrical energy at lower rates. Next, I'll come back to this quality. What parameters govern the quality of electrical energy? We'll discuss a little later. Now, similarly, what are the objectives or what are the goals of the utility? Okay. Can anybody tell what are the goals that utility wants? Yeah. What are the objectives of utility? Somebody said minimum losses. Good. Let us. Any other opinion? Profit. Yes. Any business, the ultimate motto is profit. Understand? So you do business means your objective is to get some profit. Understand? Apart from profit, is there any other thing which the utility wants? Any other thing? Brand value. See, in any business, you crave for two things. The first one is brand value. The second one is profit. Okay, understand? So, in this case, when there is a monopoly, since the public sector, since there is only one utility, in Kerala, you will get power only from the Kerala State Electricity Board. So, there is no competition. Then, brand value doesn't matter. Whether you want or don't, whether you provide quality energy or not, the customers don't have a choice. They have only one supplier. So when there is a monopoly, then there will be some compromise in the quality. Understand? So that's why always the competition brings the best to the customers. So utility objective, primary objective is profit. The second one is brand value. Customer satisfaction. Customers, if they're satisfied, they'll repeatedly come to the same supplier. Understand? So this is a perception where we are seeing the power system as a business. Eventually, in most of the decisions in the power systems are made based on the costs only. Understand? So now, what is the quality electrical energy? The quality electrical energy should have primarily two features. The voltage should be within plus or minus 6% of the nominal voltage. The voltage should be within plus or minus 6% of the nominal voltage. This allowable tolerance can change from one utility to the other utility. I am telling the general value which is taken in India. Okay, so your actual voltage at any point should be nominal voltage plus or minus 6%. Understand, this 6% value can change from one utility to other utility. Suppose if you're having a very good utility, they may not even allow 5% voltage fluctuations. But if your utility is poor, like in northeastern states where the utilities operate very very worst condition, there the allowable tolerance may be more than 10%. Okay. Now similarly, the frequency which you are getting, it should be plus or minus 1% of the nominal frequency. So the actual frequency should be within plus or minus 1% of the nominal frequency. Suppose our nominal frequency is, we know that it is 50 hertz. So allowable range here, it will become 49.5 hertz to 50.5 hertz. If our frequency lies within this range, then our frequency is within the allowable limit. Similarly, voltage, because voltage I am not telling any value, because nominal voltage changes from one point to the other point in the power system network. So, and the next feature, it should be the voltage waveform which you are getting to the customer premises should be free from harmonics. The voltage waveform you are getting should be free from the harmonics. Okay, see, only we are getting the voltage depending upon the load which we are connecting to the supply. Our current waveform will depend. If you connect a non-linear load, then your current flowing will be non-linear. So only the voltage, the cosinusoidal voltage which we are getting should be free from the harmonic. So govern the these three properties quantify the quality of the electrical energy. Understand? One is the voltage value should be within plus or minus 6% of the nominal voltage. The frequency value should be plus or minus 1% of the nominal frequency. Whatever the voltage wave which you are getting to the customer premises, it should be free from the harmonics. Understand? So far any doubt? Okay, gentlemen, because it's completely new platform of interacting, so it will be till we get adjusted, it will be a little bit like this. I hope you are able to follow my language and everything. If any doubt, you can just put a message or someone can ask in between also. Okay. Now, now, what is the challenge that we face? What are the challenges that we face in supplying the quality electrical energy? Okay. So to maintain the frequency constant in our power system network, we have to maintain the real power balance. We have to maintain the real power balance. So that means I'm writing it here. The total amount of power that is generated. There are two kinds of powers. We'll discuss them little later. So the total amount of real power that is generated by all the generators in our power system network should be equal to the total load demand that is connected to our power system network plus the total transmission losses. Okay, so at each and every instant of time, for all time t, if the total amount of power that is generated by all our generators, if it matches with the total load demand that is connected to our power system network plus total transmission losses, then our actual frequency will be equal to nominal frequency. This real power balance we have to maintain. Then only our frequency will be constant. So what is there? Why can't we maintain this one? The problem here is Demand is not in our control. Okay, at every instant of time the demand keeps on changing. Okay, and we don't know how the demand will change, when which customer will turn on which load. Can we anticipate? We cannot anticipate. Somebody may feel warm, they may switch on the AC, somebody may switch off the motor. So likewise, the whatever the demand that is existing on our power system network will be continuously fluctuating, and it is not in our control. Okay, at what we are always running to match the generation to the demand. Okay, the problem is demand can change instantaneously. Within no time there will be change in demand, but it is not possible to change the generation instantly, because whenever you want to increase the generation or decrease the generation, what you have to do in your generator, the most of the turbines will be steam turbines. Okay, depending upon the how much of steam you are passing through your turbine, your power output will be changing. So it is not possible to change the position of the valve instantaneously. Okay, if you open your tap, can you change its position instantaneously? No, it takes some time, zero point 0.3 seconds, 0.5 seconds, 1 second to change from one position to the other position. So the load can change instantaneously, but the matching generation cannot change instantaneously. That's why the frequency fluctuation will come. I'm just giving an overview. The complete topic is devoted for this topic, that is called power system stability. Okay, so this is a basic idea why the frequency fluctuation comes. Frequency fluctuation comes because we are not able to match our generation with the loads and losses. Okay, and in this case, if your generation is more, suppose if this quantity is more, then your frequency will increase, overshoot, it will cross 50 hertz. Understand? If your generation is more than the demand plus losses, your frequency will overshoot. Understand? Suppose if this value is less, then what will happen? Your frequency will undershoot. It will be less than 50 hertz. Understand? Are able to follow? So that is the major challenge, one of the major challenge in maintaining the frequency constant in the power system network. So adjusting the generation according to fluctuating load is the main challenge. Adjusting the generation according to fluctuating load is main challenge. Understand? Now, what is the challenge in keeping the voltage equal to nominal voltage? Why can't we can fix the voltage at every point to its nominal voltage? So why there is a voltage fluctuation? Why there is a voltage fluctuation? Okay, to fix the voltages to their nominal values in power system network, we have to maintain reactive power balance at all the time. We have to maintain reactive power balance at all the time. Okay, so similar like real power is being generated, reactive power also is generated by generators and capacitors. We'll discuss all those concepts detailedly. Okay, so the total reactive power that is generated should match with the total reactive power demand of all the loads put together and reactive power losses in the power system. If you can maintain this reactive power equilibrium at all time, then your actual voltages, actual voltage magnitude will match with the nominal voltage magnitudes for all time t. Understand? So reactive power balance, if you maintain in the power system, then you are going to fix your voltages to the nominal values. Okay. Again, what is the difficulty? Load. Load is not in our control. So since the load is changing, the reactive power demands of the load also will be continuously fluctuating. So again, it is a big challenge to maintain the reactive power balance. Understand? So these are the two reasons why there is a voltage fluctuation and there is a frequency fluctuation. Understand? So challenges of electrical power system. What are the major challenges? One very, very important point in our electrical power system or electrical network is electrical energy has to be generated, transmitted, and supplied to the customer at the same instant of demand. Understand? That means if suppose if I switch on a motor in my house, to run that motor I require some energy, I require some electrical energy. That energy, the energy that is required to run that motor has to be generated, transmitted, distributed to the motor at the same instant. At the same instant. That means the generator has to generate and supply to that motor at the same instant. What is the distance between the motor and generator? It will be few hundreds of kilometers. Few hundreds of kilometers. So this is the main, there is no buffer to store electrical energy. There is no buffer to store electrical energy. The electrical energy has to be generated and transmitted and supplied to the load at the same instant. At the same instant. There is no method till date to store large amount of bulk amount of electrical energy. Only we can store small packets of electrical energy in our batteries. What are the batteries? If for your inverters, you will be using lead acid batteries. Lead acid batteries. For your mobile phones, you will be using lithium ion batteries. So wherein which you are able to store small packets of energy that can last only for few hours. Whereas the bulk storage of electrical energy still is not possible. So what is the point? That is the major challenge. The electrical energy has to be generated and supplied and transmitted to the load at the same instant of demand. Understand? There is no provision to store electrical energy in bulk quantities. Okay. The third point is maintaining the voltage and frequency fluctuations of power system within operating range. So maintaining the voltage and frequency of the frequency fluctuations of the power system within their tolerance limits is the biggest challenge. Why? Because we don't have any storage facility. We have to generate and transmit at the same instant. Understand? And what are the other challenges? Our power system network, all our transmission lines, transmission towers, insulators, most of the transmission and distribution happens overhead in most of the countries. Only at very congested locations due to safety concerns, we go for underground distribution. There is no underground transmission, gentlemen. There is no underground transmission. Why? Because you cannot extend your cable length beyond 30 kilometers. It will become highly impractical. We have a lot of practical problems that we discuss in cables. So most of the transmission and distribution that happens is overhead. So these overhead conductors, insulators, towers, they are exposed to all possible worst weather conditions. Understand? So maintaining high reliability and safety when these structures being exposed to all possible weather conditions is one more biggest challenge. So it is a design challenge. We have to design our system so robust that whatever may be the condition, apart from earthquakes, it should be able to withstand and sustain those environmental changes and yet maintain the reliability, yet supply the power supply to the customers. Next. reducing the cost of generation and maintaining high transmission efficiency and optimum utilization of the installed generating capacities. All these are challenges. So this we will discuss in what is this point is that our main objective is to supply the generate the energy at lower costs, and we have to choose we have to schedule the operation of power stations such that the overall demand can be met with the lower costs. That is the main topic which we will discuss in economic load dispatch. Economic load dispatch. So there are several kinds of challenges that are being that are present in our electrical power system network. So facing all these challenges and supplying quality electrical energy to the customers is very challenging task. Very challenging task. I hope you have understood the major challenges of electrical power system. Any doubt you can post me. Gentlemen, any doubt in any of the points? Don't hesitate. You come up with your doubts. Okay. Okay, boss. Thank you. Okay. So this is a general view of a power system network, then just to get an idea that what happens. So you can see in this image, generation happens in the generating stations. The generating voltages are very low, but that means you cannot generate voltage beyond 30 kV. Let me choose it. Search the Google, what is the highest generating voltage in world? It will not be more than 30 or 33 kV, because it is very difficult to design the alternator stator for the high voltage generation. So in India, most of the cases it is 11 kV generators. In some special cases, there may be change in the generation, but the highest, as far as I know, it is around 23 or 24.5 K voltage, that too in the Kudankulam nuclear power plant in Tamil Nadu. Just Google it. I think it is 24.5 kV or 23.5 kV in it is the highest generating voltage in India. But otherwise, most of the generators, they generate the voltage at 11 kV only. Okay, because of the it is very difficult to design the heat dissipation of stator. That's why we don't go for high voltage generation. Okay, now after generation, we will step up the voltages. We will step up the voltages to any voltage. The highest transmission voltage in India, it is 1100 kV. Some test line has been erected. 1100 kV is the highest AC transmission voltage in India. Okay, so we can step up the voltage, transmission voltage, from any value to from 11 kV to 1100 kV. Understand? So the next thing is high voltage transmission. High voltage transmission is occurs. There will be only three conductors in transmission, gentlemen. In high voltage transmission, there will be only three conductors: R phase, Y phase, and B phase. There won't be any neutral in the transmission. Why neutral will not be there, we'll discuss further. Okay. So after that, there will be an intermediate substation which will step down the voltage from high voltage to medium voltage. Suppose it is a 765 kV to, I want to step down to 230 kV. Okay, so it is an intermediate substation that steps down the voltage to very high transmission voltage to a medium voltage, a lower voltage of the range of 220 kV, 230 kV, or 110 kV, depending upon the requirement. So again, the secondary transmission happens where where again it is a three-phase, three-wire system. Three-phase, three-wire system. That means In transmission, there will be only 3 conductors. Okay. After that, it will be reaching the local substation in your town or the substation in the outskirts of your city, depending upon the type of city. If it is a big city, then the city in between the city at different various strategic locations will be having substations whose voltage will be high. So from there, from the substation, again the feeders will go to distribution transformer which is present in your street. So most of the time the feeder voltage will be 11 kV. In some cases, the distribution feeder voltage can be 33 kV. So from this voltage, it will step down from to 415 volts, from 11 kV to 415 volts. Understand? So this is how the entire power system will operate. Just for your understanding, suppose this is the primary distribution where the distribution is happening, can happen at any voltage, 132 kV, 66 kV, 33 kV or 11 kV. So from there, the conductors which supply the energy to your distribution transformer, in most of the cases we call them feeders. Okay. Why we call them feeders, we'll explain little later. So this feeder that is supplying power to your distribution transformer, this feeder voltage can be 11 kV or 33 kV or 66 kV at max. Understand? So this distribution transformer will step down your voltage in from 11 kV to 415 volts, and from the secondary of distribution transformer, the conductors will change from 3 wire to 4 wire. So from the secondary of distribution transformer, what you will be having, the fourth wire will come into picture. That fourth wire is the neutral wire. The fourth wire is the neutral wire. So there will be 4 conductors in the distribution. So in this, from fourth conductor is required to supply power supply to the single phase customer. So single phase customer is being supplied from one phase and one neutral. Suppose if it's a 3-phase customers, then all 3 phases and neutral will supply power to the particular load or particular house. Understand? So this is a schematic diagram of the general power system network. General power system network. Understand? So this is the general overview of electrical power system introduction part. If you are having any queries in this, you can ask.